We've all heard it since grade school. The Earth is round. From the very first time we saw a globe in our classrooms, we were taught that our planet is a perfect sphere, a beautiful blue marble floating in space. We've seen the pictures from space. Astronauts have captured stunning images of our planet, showing its curved horizon and giving us a sense of its roundness. But here's the mind-blowing truth. Earth isn't a perfect sphere. In fact, it's more accurate to say that Earth is an oblate spheroid. It bulges at the equator. This means that the distance around the equator is slightly longer than the distance from pole to pole. This bulge happens because of Earth's spin. As our planet rotates, the centrifugal force causes the equator to push outward. The centrifugal force pushes outward, making the equator wider. Imagine spinning a ball of dough. It flattens out in the middle, right? The same principle applies to Earth. So, next time someone tells you the Earth is round, you can impress them with this fact. It's a great conversation starter and a fun way to share some science. This doesn't mean our planet is flat, of course. The idea of a flat Earth has been debunked many times over. That's a different discussion entirely. The flat Earth theory is a whole other topic that has been thoroughly discredited by science. The Earth is an oblate spheroid, round but squished. This shape is a result of the balance between gravity pulling everything towards the center and the centrifugal force pushing outwards at the equator. It's a good reminder that even basic knowledge can hold surprises. Keep questioning, keep exploring. The more we learn about our world, the more fascinating it becomes. So, stay curious and never stop seeking the truth about the universe we live in. Remember, science is all about discovery and understanding. What we know today might change tomorrow as we uncover more about our incredible planet. So the next time you look at a globe or see a picture of Earth from space, think about its true shape. It's not just a simple sphere, but a dynamic, ever-changing oblate spheroid. And who knows what other secrets our planet holds. The journey of discovery is never-ending, and that's what makes it so exciting. Let's travel through time. Imagine a vast timeline stretching from the ancient past to our modern day. Think about Cleopatra, the last pharaoh of ancient Egypt. She ruled a land of immense wealth and culture, a civilization that has fascinated historians and the public alike for centuries. Her image is iconic, powerful, beautiful, shrouded in mystery. Cleopatra's life was filled with drama, romance, and political intrigue, making her one of the most captivating figures in history. Now consider this. She lived closer to the invention of the iPhone than the building of the Great Pyramid of Giza. This fact often surprises people because we tend to think of all ancient history as being equally distant from us. It's a mind-boggling thought, isn't it? It challenges our perception of time and history, making us realize how recent some ancient events actually are in the grand scheme of things. Cleopatra lived around 30 BC, during a time when Egypt was a powerful and influential civilization. Her reign marked the end of the Ptolemaic dynasty and the beginning of Roman influence in Egypt, while the Great Pyramid was built around 2580 BC. This monumental structure, one of the 7 wonders of the ancient world, was already over 2,000 years old by the time Cleopatra was born. The first iPhone was released in 2007. This revolutionary device changed the way we communicate and access information, marking a significant milestone in modern technology. This puts Cleopatra nearly 1,500 years closer to us in time. It's a fascinating comparison that helps us understand the relative recency of her life in the context of human history. It highlights how vast history is and how much time separates us from those who came before. Yet it also shows how interconnected our past and present are, reminding us that history is a continuous thread that weaves through time, connecting us all. As we reflect on Cleopatra's life and the timeline of human history, we gain a deeper appreciation for the advancements and changes that have shaped our world. From the construction of the Great Pyramid to the invention of the iPhone, each era has contributed to the rich tapestry of our shared heritage. So next time you think about Cleopatra, remember that she is not as far removed from us as we might think. Her story is a reminder of the enduring legacy of ancient civilizations and the ever-evolving journey of human progress. History is not just a series of distant events, but a living narrative that continues to unfold. And in this grand story, Cleopatra's life serves as a bridge between the ancient and the modern, connecting us to a past that is still very much a part of our present. Literally, we all know the phrase sweating like a pig, but it's a biological impossibility. Pigs don't sweat. The saying should actually be sweating like a horse. Horses, just like humans, sweat to cool down. They have sweat glands all over their bodies. This sweat is essential for regulating their body temperature, especially during physical activity. So, next time you're working up a sweat, remember you're in good company. Horses, those majestic creatures, share this essential bodily function with us. Have you ever noticed you're a bit taller when you wake up? It's not just your imagination. During the day, the cartilage in our spines compresses due to gravity. When we sleep and lie down, the pressure is relieved. This allows the cartilage to expand, making us slightly taller in the morning. Don't worry, you don't shrink permanently throughout the day. The difference is usually small, about half an inch. This fun fact shows how our bodies are constantly changing, even when we're not aware of it. Section 5. Food for thought. Avocados are berries. We mash them, slice them, spread them on toast. But did you know avocados are technically berries? It's true. Botanically speaking, a berry is a fruit with its seeds and pulp inside. Think grapes, tomatoes, and yes, avocados. They might not be as sweet as strawberries or blueberries, but avocados fit the definition. They grow on trees, have a single large seed, and a fleshy pulp. So, next time you enjoy guacamole, remember you're indulging in a delicious berry bowl. Section 6. Space oddities. Sunsets on Mars aren't red. We often picture sunsets as a fiery red, painting the sky in vibrant hues. The warm colors of red, orange, and pink are what we typically associate with the end of the day. These colors are caused by the scattering of sunlight by the Earth's atmosphere, which is rich in nitrogen and oxygen. As the sun sets, its light has to pass through more of the atmosphere, scattering shorter blue wavelengths and leaving the longer red wavelengths to dominate the sky. But on Mars, things are a bit different. The Martian atmosphere is much thinner than Earth's, and composed mostly of carbon dioxide. This difference in atmospheric composition and density leads to a unique and surprising phenomenon when it comes to sunsets. Sunsets on the red planet aren't red at all, they're blue. This might seem counterintuitive given Mars's nickname, but the science behind it is fascinating. This is due to the Martian atmosphere. Unlike Earth's atmosphere, which scatters shorter blue wavelengths, Mars's thin atmosphere scatters the blue light more effectively than other colors. The dust particles in the Martian atmosphere also play a crucial role in this scattering process. The thin atmosphere on Mars scatters blue light more effectively than other colors. This scattering is enhanced by the fine dust particles that are prevalent in the Martian air. These particles are just the right size to scatter blue light in all directions, creating a blue halo around the setting sun. During sunset, when the sun is low on the horizon, this scattered blue light is what we see. The effect is most pronounced at this time because the sunlight has to pass through even more of the Martian atmosphere, increasing the scattering effect. The result is a stunning blue sunset that is both alien and beautiful. It's a reminder that even familiar phenomena can be dramatically different on other planets. The next time you watch a sunset on Earth, take a moment to imagine what it would be like to witness one on Mars. The differences in atmospheric conditions between the two planets offer a glimpse into the diverse and fascinating nature of our solar system. From fiery reds to serene blues, sunsets across the cosmos are a testament to the beauty and complexity of planetary atmospheres. Section 7. The science of sound your bones can hear. We usually think of our ears as the primary organs for hearing. But did you know your bones also play a role? Sound can travel through vibrations in our bones, particularly our skull. This is called bone conduction. It's why our voice sounds different to us than it does to others. We hear a combination of sound waves traveling through the air and vibrations through our bones. It's a fascinating example of how interconnected our senses are. Section 8. Language facts. Goodbye has a surprising origin. We say it countless times a day, goodbye. But have you ever wondered where this common farewell comes from? It's actually a contraction of a much older phrase, God be with ye. Over time, this phrase was shortened and evolved. It went from God be with ye to God boy to good boy, and finally to the goodbye we use today. Language is constantly changing, and even simple words can have fascinating histories. Section 9. Nature's quirks. Not all deserts are hot. When we think of deserts, we often envision scorching sand dunes and relentless sun. But not all deserts are hot. Antarctica, the coldest place on Earth, is technically a desert. A desert is defined by its lack of precipitation, not its temperature. Antarctica receives very little rainfall, making it a polar desert. This surprising fact challenges our assumptions and reminds us that nature is full of diversity. Section 10. Everyday illusions. Running water doesn't always flow down. We take it for granted. Water flows downhill, right? Well, not always. In certain situations, like a thin stream flowing along a curved surface, water can appear to defy gravity. This is due to surface tension and the cohesive forces between water molecules. The water molecules cling to each other and to the surface, creating enough force to overcome gravity's pull. It's a reminder that even everyday phenomena can hold hidden complexities. Section 11. The universe in your hands. Knowledge is power. These 10 amazing facts are just a glimpse into the vast and fascinating world around us. From the shape of our planet to the history of language, there's always something new to discover. Curiosity is the key that unlocks understanding. By embracing knowledge, we empower ourselves to see the world in new and exciting ways. So, keep asking questions, keep exploring, and never stop being amazed by the wonders of our universe.